Good morning, students. Welcome back to the online classes. So I am Syed Fasiyuddin. As you know that I am going to conduct the series of online classes for digital signal processing. So till now what we have discussed? We have discussed about the problems related to IIR filtering. In that we have started Butterworth approximation. So what is a Butterworth approximation? In Butterworth approximation, first thing, whatever the infinite impulse response filters we are considering, we have just done one to two problems we did, and we found that first thing, in order to proceed with Butterworth approximation, first thing would be we need to find the order of the filter. Second thing, we need to get its transfer function. After that, when we are taking the transfer function, the critical frequency, whatever the critical frequency we are considering, that should be assumed as 1 radio per second. The next thing what we have done, by considering the transfer function, we have to find out the value for critical frequency by using the formula of the critical frequency in pass band and then in stop band. So what is that? The frequency of the critical value omega c is equals to omega p by 10 power 0.1 alpha p minus 1 whole power 1 by 2n. What is this capital N over there? That indicates the number of samples of that particular order. So that is nothing but order of that Butterworth approximation. So that is the thing we discussed in the previous class. And after finding that one, we just want to find the poles and zeros. So to get that one, we just see one problem to find out the poles and zeros. We took the formula for poles xk is equals to sigma c e power j phi k. What is phi indicates? It's a phase. So phase, how do we find? Pi by 2 plus pi minus 2n minus 1 by pi. So the by 2n. So by taking this particular factor, we found the phase also. By getting the phase, we found the poles also. So this is the thing we discussed. In today's class also, we are going to cover the same topic, and we just want to find out the order, and then we just want to find a transfer function for given specifications. So here we do have design an analog Butterworth filter that has a minus 2 dB pass band attenuation. So here they gave 2 dB. So minus indicates what? It's nothing but we had, whenever we take any kind of gain, the gain should be taken from the RMS value, that is nothing but 0.707 dB. From there we will take minus 3 dB plus 3 dB, like that we will take the range. So likewise the negative they gave, but while we are taking the problems we will not take the minus sign, directly we will take 2. So here they gave attenuation in pass band and the frequency of pass band, at least minus 10 dB of stop band attenuation and 30 dB radian per second. So given specification, we need to write it down. So what we are writing? We are going the solution. So first thing, given conditions. What are the given condition we do have? We have alpha p, that is attenuation in pass band. It is given as 2. It's 2 dB. Or negative you can put it. Next thing, they gave frequencies. Frequency in pass band is how much? So frequency in pass band is 20 radian per second. So this is the frequency in pass band. Likewise I can take attenuation in stop band, alpha s is equals to 10 dB. So this is your 10 decibel. And what is the frequency? Frequency in stop band, it is given as 30 radian per second. So we do have all the given condition. So what is asked in the question? They asked to find design an analog Butterworth filter. So we need to design the Butterworth filter by this given specification. So for that, what is the first step we need to consider? We need to find the order. So first thing is what? We need to find the order, that is nothing but capital N. This value is the first thing we need to find the order. So how do we find the order? So order N greater than or equals to log of, what is the formula for it? 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1 whole power 1 by 2. This is a numerator divided by log of. So what is the factor in the upper side? It's stop band to the ratio to the pass band. So here also frequency of stop band to the frequency of pass band. So what I'll do it, I just want to find order. How do I get this order? N greater than or equals to, directly I'm not taking the values. So here I do have directly, so all the values I'm directly putting so that it will be easy for me to get the order of the filter. So 10 power 0.1 into, what is alpha s I do have? It's 10 minus 1 by, what is this value? 10 power 0.1 into, what is given in this alpha p? Alpha p is 2 minus 1 whole power 1 by 2 divided by log of, what is frequency in the pass band, stop band? It is 30 radian per second. This is your 20 radian per second. So this both will get cancelled. So we can get it N greater than or equals to log of So 10 power 0.1 and then 10 would be what actually? So 10 power 0.1 and this will be 10 power minus 1 by, what is this value? 10 power 0.2 minus 1 divided by log of 30 by 20 will be 1.5. So substitute this value in calculator, or else you can solve one more time, you can put the value. So n greater than or equals to log of, so 10 minus 1 I can write it as 9. 9 by 10 power 0.2 minus 1 divided by log of 1.5. So this value I need to put in calculator. So what we did, students, so we put the values of all these given conditions. Alpha s we do have, alpha s is 10 as per the given condition, alpha s we do have 10. So this thing we did. Then second thing, alpha p we do have is 2, we put it this 2 minus 1 whole is root, so it's nothing but 1 by 2 divided by log of 30 by 20. 30 by 20 I can write as log of 1.5. This is 10 power 0.1 and 10 will be 1 by 10 and 0, both will be cancelled. I can get 10 power minus 1 minus 1, so 10 power 1 is nothing but 10. 10 minus 1 log 9 by 10 power 0.2 minus 1 by log of 1.5. So what I'll do it, I'll put this value in calculator and I will find the value for this given condition. So if I'll get this one, whatever the n value is there, it should be greater than or equals to. So that value I will find out. So by taking this particular thing, what is the first thing we did? We found the order of the filter. By taking this one, what I can do it, I'll get the order. So first I'll take the order of the filter and then I'll proceed with the particular value. So I got, if I'll put this value in calculator, log of 9 by 10 power 0.2 minus 1 divided by log of 1.5. So I am getting the answer as 3.37. So if I'll put this value in the calculator, I am getting the answer as 3.37. So what is the value of n we do have? N is greater than or equals to 3.37. That means n value, what we need to do? We need to round off. Round off to the nearest highest integer. So whatever the values I do have, I need to round off to nearest highest integer. So what is our nearest highest integer for this? I'll get n is equals to 4. I can put the 4 because it's 3.37. Greater than 3.37 would be the 4. So this is which order? It's nothing but fourth order. So we found the order now. What is the next criteria, students? After getting the order, we need to get its transfer function for fourth order. So what is the fourth order transfer function? First, in the denominator, we need to get the polynomial. In the previous class, I have explained you, when we had the order of the filter for Butterworth approximation, if n is equals to 1, denominator should be s plus 1. N is equals to 2, s square plus root 2s plus 1. N is equals to 3, s plus 1 into s square plus root 2s plus 1. Likewise for n is equals to 4, I gave s square plus, I gave some constant value. While I am explaining this thing, I said you, whenever we want to take the values, those are denominator constant polynomial we need to consider. So what is this n is equals to 4 denominator polynomial I do have? I have as h of s. What is h of s? 1 by s square plus 0.76537. This is a constant value, students. So we need to remember this value while we are taking the polynomial. So into s square plus 1.8477 s plus 1. Okay, so we got the transfer function. What is this called? This is called it as transfer function. Clear? So this is the second step. We got the first step to solve. We done with the second step. So what is the fourth means? If you multiply s square and s square, it is s power 4. What is s power 4 means? It's fourth order. Likewise, you can correlate these values. Yeah, likewise, you can remember. So for n is equals to 1, there is a denominator polynomial we have learned. For n is equals to 2, denominator polynomial is different. N is equals to 3, n is equals to 4. Till that, we have seen different polynomials. Right? For n is equals to 1, we do have s plus 1, n is equals to 2, s square plus s plus 1, n is equals to 3, s plus 1 into s square plus root 2s. This already I have given. N is equals to 4, this is the value. Clear? So these are these are the denominator polynomial for that particular transfer function for using Butterworth approximation. So we did h of s. What is the next criteria? What is the assumption here, students? So we are assuming that the critical frequency. What is the critical frequency? Omega c is 1 radian per second. Right? So but this is assumption. What is the next criteria we need to do? We need to find the transfer function HA of S. That is nothing but S by omega C. Wherever S is there, that value we need to find out. First thing, we need to get what is omega C. That is nothing but critical frequency. So till now what we have done? We took the order, we found the order, then we put in transfer function, we got the transfer function. Next criteria, we need to find the critical frequency omega C. After getting the critical frequency, we can substitute in equation 1. Let us assume this is your equation 1. So what we'll do it, after getting these value, we will substitute in this given condition and we will find out the transfer function. So we will get the transfer function by looking into its particular value. So before proceeding this thing, you need to remember, students, so what is the orders of this? What is the polynomial denominator? N is equals to 1 is S plus 1. N is equals to 2, here S square plus root 2. Here is root 2 is there. Root 2 S plus 1. This already I gave in the previous content, but in order to keep on reminding you, you should remember these values. That is a constant value for that particular Butterworth approximation. We can derive this thing, but we don't want this all derivation. We only want the application part of it. That's the reason we are taking the constant directly. N is equals to 3, S plus 1 into S square plus S plus 1. N is equals to 4, S square plus 0.7636537 S plus 1 into S square plus 1.8477 S plus 1. So these two we have to put for fourth order. So N is equals to 1 means, you see, the power of that would be 1. N is equals to 2 means power of that would be 2. N is equals to 3 means S into S square would be S power 3. N is equals to 4 means S square into S square, S power 4. So this is the way these values of that particular polynomial has been obtained by taking the phase of it. So next criteria, students, so we got the transfer function. Next is that we need to find the next step. The next step, we need to find the critical frequency omega C. Right? So how do we find omega C? To find the omega C, we do have the formula. What is that? Omega P by 10 power 0.1 alpha P minus 1 whole power 1 by 2n. Right? By using the passband. You can use by using the stop band also, you can find out the value. So by using the passband, I took it is equals to, we do have one more, right? Omega S stop band by 10 power 0.1 alpha S minus 1 whole power 1 by 2n. You can go with passband, you can go with stop band. So if you are going with passband, you have to take the attenuation in passband. If you are going with stop band, the attenuation needs to be in stop band. If you are taking the frequency of that passband, this is also passband. Don't take like this omega P and alpha S. No. Always the frequency and attenuation of the same particular band only you need to consider in order to find out the critical frequency. So next criteria, we are finding the critical frequency. As per our steps for designing the Butterworth approximation, we are proceeding in this way. So now omega C is equals to, what is omega P we do have? So in passband it is 2. 2 by 10 power 0.1 alpha P. What is alpha P? This is your alpha P only. This is your 2. What is the frequency of this one? It is 20. Right? Passband frequency is 20. Minus 1. Whole power 1 by 2. What is N we got just now? We found the order of the filter. What is N value we do have? 4. So I can put it here 4. So I got 20 by 10 power 0.2 minus 1 whole power 1 by 2 4s are 8. So we got this thing. If I'll put this value in calculator, already I just put it. I got 21.38. I found just now 3868 radian per second. Right? So this is my value I found by putting this in calculator. You put this value in calculator, you will get the direct answer. So what we got now, students? We got the critical frequency omega C. What is the next criteria? We need to find next step, HA of S. How do we find HA of S? S by omega C. So what is S value? S is as it is. What is omega C we do have? 21.3868. So wherever S is there in the transfer function, in which transfer function? H of S. What is H of S we do have? 1 by S square plus 0.76537 of S plus 1 into s square plus 1.8477 of s plus 1. This is our transfer function, students. So what we are doing, we are putting the values. So if I'll put the value, what I'll get? 1 by, what is this s now? S is written as in this form. So whatever the s is there in that s we are replacing by this particular factor. So in that, what I'll write? S by 21.3868 whole square plus, this is as it is. So what I'll write? 0.76537. What is s now? S by 21.3868 plus 1 into second factor. What is the second factor? S by 21.3868 whole square plus 1.8477 s plus, s value is what? Root of s by 21.3868 plus 1. So this is the way we substituted the value. So what we did, wherever s is there, that s value we replace with this particular factor. So in that we put these two values. What is the next criteria? We need to simplify this one. So how do we simplify, students? So what is the value we do have? See here. Here also 28 in denominator, here also in denominator. These two value I can shift in numerator. So what I'll get? 1 by whole, I'll put like this. I'll take the LCM. What is the LCM? I'll get 21.3868 whole square. Right? Here I get s square plus this value 0.76537. One value gets cancelled, but still one more will be there, into 21.3868 of s plus this is what? 21.3868 whole square. We cross multiplied. We'll take by 1. LCM will take it, we'll multiply. So this is the first factor. Similarly, we can write for the second factor, same way. Put this in root 21.3868 whole square. This s square as it is, this value, whatever the value, 1.8477 into 21.3868 plus s is there. So here I'll mention s here, or else I'll put it here as s plus 1 is what now? 21.3868 square. This is the value. So now this is in denominator. These two value will come in numerator. So what I'll get the answer? So put this thing in the calculator. Division by division will come in multiplication. So what we'll get? So we will find that value. So we will solve that one and we will find it. So before doing it, just note it down this thing. Then I'll proceed with complete solution. So what is the value we do have, students? So we had this factor. So that factor we are substituting in the formula. So if we put in the formula what we did, so wherever s is there in that h of s, we substituted by critical frequency. So 21 is there, 0.38, here is also there, here 1 is there, here s square is there, that we change it, and this also. What we did, we changed all the factors. Next thing, we need to find out the value. So how do we find the value? We took the LCM for this factor and this factors, we got this one. So in division by division, it will come in numerator. So what we get? So we get HA of S. This is your HA of S, the whole transfer function. Whatever we do want to find, this indicate here HA of S. This we are finding. So HA of S is equals to 21.3868 square into 21.3868 square by this particular factor S square plus, if you multiply 0.76537 with calci, so what I'm getting? 16.38. I'm getting 16.38 in calci, 16.3686. 3686 of S plus 1. 1 is nothing but the value. What we got? 457.394. 457.394. So this is a one. What is this value? This is nothing but square of this factor. So that one we got it here. Likewise for the second factor, S square plus. Next, what is the next factor we do have, students? Second factor is what? What is this value here? 1.8477 into 21.3868. If you multiply, I got this value as 39.5176. 39.5176 of S plus square of it. We will get same factor, 574.394. Okay. So if you multiply this square into square, what I'll get? I'll get HA of S is equals to 0.2 0.20921 into 10 power 6. This value I have put in the calculator. I found this thing divided by the same factor. What is the first factor? S square plus 16.3863686 of S plus 457.394 into S square plus 39.5176 of S plus 457.394. This is the actual transfer function by taking the critical frequency. So what are these various steps we did, student? First we found N. We got the N. What is the second step we did? We found the H of S by assuming your critical frequency as 1 radian per second. Next step what we did, students? We found the critical frequency. After getting the critical frequency, what is the next criteria we found? We substituted in H of S this critical frequency. How do I substitute this in H of S? By making as HA of S. How can I make HA of S? HA of S can be made by taking S tends to S by omega C. Then I found the last answer, HA of S. That is my particular answer. So this is the way you can solve the given problem for all type of specification. So all these steps you need to keep in your mind while you are solving these kind of questions. So you need to remember the value for your N. How do we get N? By taking the log factor. Log of 10 power 0.1 alpha S. In numerator alpha is there, in denominator alpha P. Attenuation in stop band, attenuation in pass band with root divided by log of omega S, that is nothing but stop band frequency ratio to the pass band frequency. So we took these two factor, we got N greater than. So whatever the values we do have, we got 3.37. The N needs to be more than that. So for that what we did, we took that value more than 3.37, that is nothing but 4. So we got fourth order. So what we got N value? We got fourth. So what is this fourth means? We need to assume what is H of S, denominator of H of S. The fourth order, what is the value we do have? S square plus 0. Whatever the value we do have in the transfer function, 0.76537S plus S square plus 1.868477S plus 1. We got that. So that is nothing but this is the fourth order. We found the value of it, and when we see the x square plus 0.7657S plus 1 of, we got one more factor, S square plus 1.8477. This you need to remember, plus 1. Okay, that S value we put it here. Then we took the formula for this one and we found critical frequency is 21.3868 radian per second by taking the pass band. So you can go with stop band also by taking omega P, by taking alpha P. By taking these two factors, I found critical frequency. That critical frequency, I want to find out my actual transfer function by considering this particular critical frequency. So for that what I did, I just want to put it this value. I put it this value in HA of S and I found the particular functions. So this is the way your problem for Butterworth approximation can be solved and can be found by taking these all parameter into consideration. So we just found the values of your order, then the transfer function, then critical frequency, and then actual transfer function by considering the critical frequency. So this is the way we have done with one problem. So in the next class, we are going to continue the same topic, the topic what we discussed for the Butterworth approximation. The next topic for that would be the Chebyshev approximation for IIR filtering. In the next class, we are going for Chebyshev approximation for IIR filters. It also had the same kind of steps, but the formulas are different. So that is another scientist who explained about this, finding the infinite impulse response of the given filter. All types of bands you need to consider, like stop band, pass band, critical frequency, order of the filter. Then you will be having the concept of your phase of that one by taking these poles and zeros. So by taking these all factors, we are going to see that particular functions into consideration for finding the question based upon the Chebyshev approximation. In Chebyshev approximation, we do have two types, type 1 Chebyshev approximation and type 2 Chebyshev approximation. So those things we will see in the next class. But in today's class, once again I'll tell you that what we did. In today's class, we found first thing order. And how to get the order? to get the order, we should have 4 parameters. What are those 4 parameters? First parameter is about attenuation in the passband, frequency in the passband, attenuation in the stop band, and frequency in the stop band. So by taking these all 4 parameters, we found the order of the filter. As soon as we done with the order of the filter, we have to find what is the transfer function. So how do we get the transfer function? By taking the value of n. If it is n is the first order, we do have denominator polynomial which is constant for finding that particular value. So what is that? N is equals to 1 means s plus 1. That means the power of s needs to be 1. For n is equals to 2. What is n is equals to 2? That means the coefficient, the power of s needs to be 2. That is s square plus root 2s plus 1. Right? So by taking these constant values, we found the second order. For third order also, s plus 1 into s square plus s plus 1. So this s into s square, you can get it as x power 3. So this is also what? Constant value for third order. For fourth order, we did the problem as per the given values. So what we did? We found the transfer function by assuming the critical frequency as 1 radian per second. So this is the things we did. Next criteria. What is the next thing we need to find? After getting this next criteria, we need to find the actual transfer function. So actual transfer function, how can you get it? HA of S. HA of S. In order to get HA of S, we need to find the factor. What kind of factor we need to find? We need to find the critical frequency. So how do we get the critical frequency? By looking into its passband frequency and the attenuation of the passband. By taking this one into consideration, we can get it. Or stop band frequency or stop band attenuation, by taking that formula, we can substitute and we can find out the omega c. So that omega c, wherever s is there, that should be s is divided by omega c. If you did these two things, we can find actual HA of s. Right? So these things we did, and we found the transfer function. We cross multiplied, we simplified, and we got actual HA of s is equals to multiplication of these two factors. By multiplying, by using the calculator, I got 0.20921 into 10 power 6 divided by s square into what we did. I multiplied this factor 21.3868 into 0.76537 of this factor. I multiplied, I got this one. Okay, you may get approximate answer. It's not that calci may have plus or minus 0.001 error. Okay, so you will not get the exact value, you will get 16.3676 whatever, but you will get the approximate value for it. So it is 16.3686 of s plus, by taking 21.3868 whole square, if I do it, I'll get the answer for this. That is the first particular denominator we found. Next thing, what I need to get? I need to get this thing s square plus 1.8477 into 21.3868. This factor I multiplied, I got it as 39.5176 of s. So this is the value I get. Yeah, 39.5176 of s plus, if I do 21.3868 whole square, I got it as 457.394. So this is our in denominator. Numerator, if you multiply, you got that factor. So this is the way we found the problem. Keep on practicing. This is a 10 marks question for sure in exam. They can either give Butterworth filter or Chebyshev filter for 10 marks. This is the sure question you will get from unit 2. Okay, so in the next class we will see the Chebyshev approximation designing. It has also have the same order formula instead of log, where we'll use cos h inverse x. The inverse hyperbolic function we will take, and we will find out the order, transfer function, critical frequency, then poles and zeros, and then by putting the critical frequency we will get the transfer function. Thank you for today's class.